Hello and welcome back to another tutorial video. In a previous video, which I'll be linking in the top right, you can see the link. If you haven't looked at that, then go and watch that, although you don't need to. But then in the previous video, I went through some of the options available in CST Studio to create animations, and in this video I'm going to be specifically focusing on how I created this animation. So this animation I also showed in the last video, which shows a particle beam moving through the cavity and shows you how the wake fields are formed, because you could see that when the particle was moving through the beam pipe, there were no wake fields generated, but then when it got into this, you could see the wake field forms, and then this would really drive home the point of how Wakefields are created to an audience. So I'm going to be showing in this video how I created this. Now I've already made the video, and the simulation takes quite a while, maybe about 10 minutes or so. So I'm just going to be showing a demonstration of how I got this. So let's dive right into it. So you set up your Wakefield solver. There's a video, and in my earlier videos I already showed up how to set up simulation for Wakefield solvers. However, for the sake of demonstration, we do not need to, or usually we do not need to solve for a very long wake length. We just need a short wake length, as short as enough to allow the beam move through the cavity once. So but then before we do that, let's have so I already went ahead and gave some settings. So this is for the Tesla cavity, so 1300 megahertz. Already put a maximum frequency of 2000. 4000, you could use a different frequency depending on what you want, and then set up the boundary condition. So basic setup. Now what is missing currently, the particle beam. So I want to define my particle beam, and since this is just for demonstration, I'm going to use 25 cm. I could also use shorter, but then pay attention that this would increase your mesh size. So kind of being conservative here of the value. So 25 millimeters. And then I don't really need to do any of the other settings because I'm not creating a simulation to calculate any value at all. So I'm not interested in, with this simulation, I don't want to use it to calculate the loss or kick factor. I just want a simulation um, of the fields. I just want an animation of the fields moving through the cavity. So I think this is pretty much it. And then click on OK. And normally, if you were running a Wakefield server, then you would go ahead and put a wake length and then run it. But first, we need to monitor the fields. So we go to field monitors and then field monitor, and I selected the E field monitor. Now you could monitor this for a particular frequency. Now from your hidden mode solver, you get distinct frequencies in the spectrum, and then you have the field profile. So it doesn't, at least to me, doesn't really make sense to monitor frequency here, but then you could go ahead and put 1300, and then when you run this, you would get the fundamental mode, or at least close to, depending on how accurate your simulation is. But then you'd have a field oscillating at this particular frequency, and then it should be the fundamental mode. But then I want to look at the evolution of the electric field over time for all the modes. So over time, and then I could change the step width to whatsoever I want, and then I could also specify an end time, but then I'm not specifying this, I'm specifying a step width, and then I'm interested in all the domains, so I'm not using any sub volume. And basically I add this and that's it. Now you could go ahead and add different field servers. You could also add for each field and then time, and then do the same settings. And okay, so you could add for anything you want to monitor for the whole time. So that's pretty much the setting. Now I mentioned earlier that we do not need to simulate a very long wake length. We only need to simulate a wake length long enough such that the particle moves through the cavity, if that is what you want. But then for this video, this is what I wanted. I wanted to show the particle be moving from this end to this end, and then showing the wake fields that are left. I'm still resonating even after the particle had gone. So the wavelength I use is the time. I mean, you have that the time you should simulate should be enough for the particle to move past, and then you could do your calculations. But then the easy way is the wavelength should be you just add a few millimeters or some millimeters to the length of your cavity. So if I want to get the length of my cavity, I click on P and then I select this point, and then I click on P again, I select this point, and then I can see here that it's about, okay, 1.5 meters. So if I should go to my wavelength, then I would put, let's say, 2 meters, so 2000 millimeters. And that's it. Once you run this, in the end, what you have is, so I would apply this and then save. So I already went ahead and run this, but then for a different peak length I used 5000, but then in the end I didn't need to simulate the entire 5000 steps. So these were my settings. For the monitor I used 0.01. You could use anything, I just selected 0.01, and then in the end this is the result I had. So I had this field result. Now I would have animated this field, but then it takes some time, so I'm just going to go to specific time steps. So if I should go to 1 nanosecond and load it, you see that the beam is already moving. Then if I should go to 7 nanoseconds and load it, then you would see that, okay, the beam is already passed. Let me see 4. Let's add the middle. Yes, so you could click animate on this and then it goes through the frames one after the other, but then it takes time to load each frame, and I do not yeah, have the time to wait for it. So like with all fields, you could either animate or save it. So you have two buttons, and then the bottom one, which is this drop down arrow you see here, once you click on it, you go to save video, and then you could, yeah, play around with these settings. Now this calculated 2239 samples because the wavelength I used was 5000, which was unnecessary. I don't know why I did it, but then it was unnecessary because in the end I only needed 700 frames of this to make my video. And then if you should see the video here, you have that it also shows the number of, oh, I think, wait, was this 700 or 2000? No, I think it was 700. Yeah, 700 out of 2239 frames. That's what I needed. So yeah, and that's it. You have this video, and then this clearly shows the Wakefield. Now you could turn this off if you do not want it to appear in your video. So you could go ahead and go to view. Okay, I will have to cancel out of this, and then I can go to view, and then I turn off maybe the axis. What else can I turn off? I can turn off the labels, so hide all labels. Now this is supposed to be hidden. Wait, okay, it's not hidden. Yeah, but then I think you could show all. I think you could play around with this to see what you can hide from the scene or not, or you could in the end maybe export the video and then crop it. If you only need this part of it, you could crop it in PowerPoint or some other software. So that's it for this video. In subsequent videos I'll be making animations from some other simulations type, and yeah, that's it. If you have any questions, please leave it in the comments, and I'll try as much as possible to get to it on time.